we start to have again 2 parallel sessions every half hour. So the first parallel session you have is the Lean Journey to Excellence at a Consumer Health Product Supply Center, and this is Bayer, Indonesia. Then you have another parallel session. Haishi Bai, principal architect of Microsoft, is going to be talking about using AI to boost lean practices. And here on the main stage, I already see my friends from Turkey. Good morning, Gulsah, Kaya from Wagner Cablo, and Nezi Soydan, her moderator from Lean Institute Turkey. Guys, the floor is yours. Thank you very much for being with us and have a great session.
Thank you.
Thank you, Roberto. Good morning from Turkey. I'm Nezi Soydan from Lean Institute Turkey. Welcome again to our Lean Global Connection. In this session, there is an interesting presentation about how to reduce overstock and material obsolescence through customer order reliability analysis. In this presentation, you will not see any standard Lean tool, but a tool and an approach designed to address to the specific problem of the company. Now, listen to production planning manager Gulsah Kaya from Wagner Cable to learn about it. Okay, it's your turn.
Thank you. Good morning, everyone. First of all, I'm very happy to be here, and today I'm excited to share our project with you. And this is the agenda for today's topics. And first, about Wagner Cablo. Wagner Cablo was founded in 1992. It's a Turkish company, and our main location is in Antalya, Turkey. Company started Lean in 2007, and it has approximately 18 years of experience in the Lean manufacturing. And as our General Director, Mr. Hilmi Ünsal, has said, Lean is a part of our company culture. And here you can see the products that we manufacture. Our company operation in the harness industry, mainly manufacture for the automotive industry, but focusing on the smaller harnesses rather than the main harnesses. As you can see here, it is possible to see our production in the lighting, seat belts, and mirrors. Since the beginning of this year, we have manufactured 509 different products and using 1,446 different raw materials. And it is quite a complex structure for us. What is the main problem that led us to undertake this project? As you know, during the COVID period and continued in the post-COVID era, the first supply chain crisis began. And the automotive industry was greatly affected by this. Following that, the material lead time increased dramatically. We see 110 weeks delivery times, and at one point, 30, 40 weeks became norm. And by the way, still some individual parts are affected. And electrical vehicles also brought some challenges to the industry. And some products ended suddenly, the others had big order fluctuations. And along with all this, we started having lots of overstocks in our raw materials. And after all of them, what was the effects? Especially, we faced very high costs in 2022 and 23, as the high logistic costs, inventory holding stock cost, obsolete material cost, and also our relationship with customer and supplier became really strained. From these consequences, the idea of developing a risk analysis method has emerged. And first, what have we done? First, we built a team consisting of members from different departments. And of course, Mr. Nezi Soydan from Turkey Lean Institute support us in this work. And our goal is to minimize the overstock and obsolete material, ensure customer orders reliability, and optimizing inventory management. Then we have identified the risks. The most critical risk, obsolete material cost, of course, and then followed by order fluctuation, supplier delays, and the project unpredictability. Later on, we began collecting the data. Customer data from the past 6 years was analyzed, and focusing on historical customer orders of actual demands, lead times, purchase orders, and previous issues with overstock and obsolete materials. Critical materials were identified based on the several criteria. In the end, team focused on 2 key factors. First one is lead time and the total material cost. Total material cost means purchasing order cost plus material on hand cost. At this point, based on our customer agreements, we identified the materials with a lead time greater than 24 weeks and total material cost exceeding 30,000 euros as critical. We worked on several case studies, and we mainly focusing on our negative experience. Based on this negative experience, our studies show that it's possible to detect some early warning signals during the significant fluctuations or order cancellations. It is possible to identify deviations between the past orders, future orders, and actual shipments. Based on this, 2 distinct analyses were developed. And these analyses were developed with our IT team software developers using our in-house software program, and we called it WKA. And currently, we run this analysis once a week. It is processing approximately 4 million records in just 5 or 6 minutes. And about the analysis, we generally receive orders from customer via EDI, and these orders often cover very long periods, but typically represent the upcoming year. And orders updated every week, so which means they can fluctuate every week. Therefore, we run this analysis weekly, and also every 2 weeks, we organize a meeting with the team to assess the overall risks. And as I explained before, we developed 2 analyses, and analyze is comparing the past orders with actual shipment, and analyze to show how future orders fluctuate. I will explain in more details in the next slides. And analyze one is about past orders, and analyze the deviation between actual shipment and past orders. It has 4 parameters. First one is the analysis period. How many weeks back will be examined order fluctuation? And the second one is control period. For how many weeks will actual shipments be compared to past orders to calculate the deviation? Sorry. Alarm level, then what will the alarm be based on the calculated deviation? And the last one is alarm period. How many weeks in a row at the alarm level will trigger a warning? I want to explain this with a schema. It might make things more clear. For example, if we choose 24 weeks for analysis period on timeline, we go back 24 weeks from the current week. You might wonder why we selected this. This is because nowadays our actual lead times for raw materials is about 24 weeks. And if we choose 8 weeks for the control period, it means that analyzers compare actual shipments from the previous 8 weeks and the total annual demand figure from the prior 60 weeks. And as shown in the figure from week to 60, the algorithm calculates the annual demand for this control period on week-by-week basis. As the alarm level, if there is more than 50% decrease with 2 compared figures, the analyzers will trigger an alarm. And additionally, we have set an alarm period, meaning that if the alarm continues for a certain number of 4 weeks, it's considered a real alert and we must take action. And analysis two about the future orders and highlight deviation similar to analyze one. And it has 5 parameters. One is analysis period 4 weeks. How many weeks back will be examined order fluctuation? And then control period 4 weeks. How many weeks of past and current order we compared? Sorry. And third one is analysis period 4 months. How many months will before and after orders be compared? And control period 4 months. How many months will be compared internally? And the next one, alarm level, like before. And like analysis one, let's explain with a schema. On the timeline, let's say we are in week 45 and it's November. If we selected 20 week for analysis period, algorithm will go back 20 weeks from the current week. Then if we choose 4 weeks for control period of week, as shown in figures, it will compare the last 4 weeks with the first 4 weeks of the timeline to identify for the future control issues. For the control issues, we analyze them on a monthly basis. And if we set the analyze period to cover the next 6 months and choose 2 months control period, for instance, in the short term, the initial 2 months are December and January, and in the long term, the final 2 months are April and June. In this case, we look at the deviation for both short-term and long-term period. For the short-term period, which is December and January, we compare the total order demand for the first 4-week control period with the deviation orders from the last 4 control period. Based on the alarm level we set, the system will trigger an alert if we need it. And for the long-term period, which is April and June, we compare the total order demand for the first 4 weeks control period with the deviation order from the last 4 weeks control period. Based on the alarm level we set, the system will trigger an alert if needed again. And now let's take a look at the cases, so I think we can understand them better. This case one is a real example from our company. And this chart is an actual output from Analyze One and represent a real report as shown here. The blue line shows the total annual order calculated using parameters I explained before. And similar, the green line shows the actual shipments, red line shows deviation, and the yellow will indicate an alarm. And currently we are in week 40, and after running the analysis, as you can see, there is no alarm here. The deviation about 30%, which is below the alarm level. And now we are in week 41. After running this analysis again, there is still no alarm. And again, in week 42, there is no alarm. But when we reach week 43, after running the analysis again, we see the yellow alarm. You can observe the gap between actual shipment and demand. However, since this is the first occurrence, we are monitoring the situation without taking any action. And in week 44, we still see the alarm, and we are continuing to monitor the situation, still waiting. And week 45. When we reach week 45, we still the alarm, but if we chose alarm period of 6 weeks, now we must start to take the actions. First, check the analyze tool. The chart from the analyze tool shows the demand for the first 4 weeks of each month. Then we look at the demand for the months in the last 4-week period, and we can observe the deviations. Deviation 1, short-term orders for December and January have decreased by 35 compared to the previous period. And the deviation 2 for the long-term orders for April and June increased by 60% compared to the previous period. And for this case, analyze 1 triggering an alert, also analyze 2, the future demand trend analysis is triggering an alert. It means that the customer postponed their orders. They increase the long-term demands, and which means we are overstocking. And if project is approaching end of life, we face the risk of obsolescence material. And based on all of this, we started taking action. We informed the customer, our customer, and they accepted the rejection. And they also contact with their own customer, and they said end of line is near. So we identified the overstock material costs. We also connect with our own supplier and did some cancellations. And then our customer was informed about the potential obsolescence material cost, and a material guarantee was requested. As a result, the potential obsolescence cost was reduced really good, 30,000 euros to 3,000 euros. And the next case is about raw material. We can perform both two analyses using the same logic for the raw materials, and algorithm calculate the usage instead of demand. This raw material has been selected by the customer. Its origin Japan, and lead time is about 55 weeks, and using over 30 projects, 30 different projects. And we know some of these projects are nearing their end of life. So this is one of the most critical part for us. As you can see here, it is always triggering an alert. And this is the first raw material code we started to track with this project. We have been tracking this since the end of February. And here is the analysis tool for the same raw material code. You can see the short-term deviation as deviation 1, and for long-term deviation 2. And again, the analysis 1 is triggering an alert, but analysis 2, the future demand trend analysis, that does not raise any alarm because the decrease is within acceptable range. But demand shows a continuous decline. Analysis 2 is acceptable, but the lead time is really significantly high. As we approach the final period, actual usage drops sharply, as in analysis 1. And results, we are not placing orders according to actual demand. For the current orders with the 55 weeks lead time, ordering 25–30% less than actual demand. And we have received a purchase guarantee from the customer for this raw material, which is a really important point for us. And what are the results of this project? We achieved a 53% reduction in obsolete material cost and 13% reduction in the stock days. This was one of the main goals of our project, and I think the results are great success from February to today. We have also improved our agility in responding to customer and supplier side, and identify the key customers' behaviors for the future collaborations. And what about the next for this project? We want to align to material planning and Heijunka, and also continue the improving stock level optimization and responsiveness to demand changes and enhance flexibility. And these are my colleagues with I worked on this project. I thank them all very much. And also I would also like to thank Mr. Nezih Soydan for his guidance on this project, and our General Director, Mr. Hilmi Ünsal, for his continuous support. That is the end of my presentation. I'm happy to take any questions now.
Okay. Thank you, Gulsah, for presenting and sharing your experiences with us. I have a question for you. What was the approach and response of your customers when you used this system and warned about their unreliable orders?
Some of the customers really like, because sometimes they also have no information about the some figures, because they have we are like tier 2 and tier 3, and they are tier 1, and we are not sent our products directly to the OEMs. So they contact with their OEM site, and they had some figures. After we ask the questions, we give them to the information about the fluctuations. So I think there's no problem for them. They really okay for this.
Okay, thank you. For how long are you using this system, and how many times these alarms had triggered and you take action about it?
We use this system, I think, from the end of March, and maybe 3 times it's get alert, for big alert, I mean. And we all inform to our customer and give them the feedbacks.
Okay. There is another question from Kulash. What was the difficulties you had during the implementation of this system?
Difficulties. I think difficulties about the customer orders, because as I explained earlier, every week they send us a new EDI. We update every week the orders, so it means that every week lots of information. Like I explained before, 4 million different row, different data are in processing every week. So it is the most, I think, the most one.
I see. Okay. Are there any other questions from our participants? Okay. I think that's all. Thank you for all participating in this session. I hope this system will help the presenters, the participants to address their similar problems. Okay, bye.
Can you hear me? Hello, can you hear me?
Hello.
Hello.
Yes.
Ah, good. Yeah, we have a few more minutes, so I was just wondering if there's something else that we can talk about together, maybe. Did you have any, and Nezih, I don't know, you have any other questions or anything, any other thoughts that you would like to share with the audience about this presentation? We have another 5 minutes or so if you want.
Okay. Gulsah?
No, thank you.
Okay. Well, let me ask you something then. Oh, Chris is there as well. Hi, Chris. No, we're on.
Sorry.
There you go.
So,
Priolo, Chris, yeah.
We can talk a little about the challenge. A lot of people don't know about the challenge you left yesterday also. So let's
forget about this. Yes, let's do that.
So
let's do that. So
let's just
I've
thank
seen
our friends
already
there
a few
from Turkey.
people. Yeah. So a few people have already published their selfies that we talked about yesterday. I've seen a few last night and another few this morning, but I wanted to encourage people as a reminder that we have 2 books that we just published that we are giving out to free people who will participate in the selfie challenge. What is the selfie challenge? We're just asking you guys to take a photo of yourself watching the Lean Global Connection and using the hashtag LGC24 and tagging us at Lean Global Network. We just want to hear why you are joining this event, why you're here, why you think it's important that we come together as a community. And then we'll randomly select 3 of you participating in the challenge. And we will give you, as a prize, the 2 latest books that we published at the Lean Global Network. One is Daily Management to Execute Strategy, and the other one is Upgrade to Hospitality Excellence. So the first one, it was written by the team in Brazil, actually, Jose Ferro and Robson Gouveia. And the other one was written by people here in Spain. I'm actually one of them. And it's a story of a hotel, the transformation in a hotel. And it's written as a novel, but it actually contains a lot of practical tools that you can use if you work in the hospitality industry, and not exclusively if you work in the hospitality industry. So I really encourage you to participate in this challenge, and you can win these 2 books, which are great publications, and the latest that we have here, that we have put out here at the Lean Global Network.
Yeah, so again, that's important for people to know. We still have a few hours to go, so they have a chance to participate. We will select between the ones that will be sent. So everybody still has a chance to win this prize and learn a little more and share their knowledge also and share their selfies online. Will be nice.
That's right. And I encourage people to do it. The easiest way to do it is LinkedIn. I think we received some emails as well with the selfies. That's fine. But the easiest way for us to find them is LinkedIn. So I would suggest you post them there. And you have time until, I would say, 1 p.m. UTC today, which is in about 5-6 hours. Sorry, 1 p.m.